Yeah, myself is Dr. K. Manikanta. I am from the Department of ECE. Today, our course is on analog CMOS IC design, and here we will know why analog CMOS IC design, what is the purpose of analog, and what you are coming from CMOS rather than NMOS and PMOS. And we have different types of FET devices. Rather, those we are using CMOS circuits mostly nowadays. Why you are coming to CMOS compared to other devices? We'll know about after this course. So here we will start with the what we will get after knowing the subject. Means first we have to check the what the units we have, and from that units what is the object, and from that object what we are getting. Those are called course outcomes. What are the course objectives and what are the course outcomes? Those will know about in this presentation. So if you see here, the MOSFET is of two types. First one is PMOS and second one is NMOS. Here if you see the symbols also I am displaying here, PMOS symbol and NMOS symbol. This is the P channel MOSFET and this is the N channel MOSFET. Whereas in the PMOS channel we will done it with the N substrate, where in N channel we will done with the P substrate. So what about CMOS? Why you are talking about NMOS and PMOS means before going to CMOS we have to know about the PMOS and NMOS. Why? Means CMOS is the combination of both PMOS and NMOS. So that's why we will go to the before going to CMOS technology we will know some knowledge on the PMOS and CMOS. So that's why I have represented the symbols here. The paddling or combination of both PMOS and CMOS is nothing but is nothing but CMOS. Now we'll see this presentation contains both course objectives and course outcomes. What are the course objectives? Why you know about this means before studying any course, we have to know what the use of that course. What is the use of that course? If I learn, what I will get from the course, that we have to know. So before going to that, we have to know the course objectives, and before after knowing the subject what we have get, that will be known before knowing the course. So here we will see course objectives and course outcomes, and that one course syllabus. What is course syllabus? Course syllabus already we know very well. The course syllabus of the is divided into 5 units, that is unit 1, unit 2, unit 3 and unit 4 and unit 5. The first unit is a basic MOS device physics, and the second unit is differential amplifiers and current mirror circuits, and the third unit is frequency response and the noise, and the fourth unit is CMOS operational amplifiers, and the last unit is stability and frequency compensation. Here course objectives. The next slide is on course objectives, what the students will able to know. What able to in this video you can do the course objectives. By studying this course, he is familiarized with the MOS device and its modeling. he's familiarized with the MOS devices and its modeling. Means he can know the what is the MOS devices and what is the use of MOS device and how the current will be changing with the input voltage will know by this unit. And the next one is learn and design analog CMOS circuits. And after studying the MOS devices, he has to apply that knowledge on the different circuits, and after applying the circuits, that can able to know what is the operation of that circuits by using the CMOS rather than other MOSFETs. And then analyze CMOS based amplifier frequency response and noise. And after that, for every circuit you have to know about the analyze CMOS based you have to know about the noise and frequency response, because it is very important for the every device. Every circuit should have a high frequency resolutions due to high frequency usage in the. And learn and design operational amplifier with CMOS technology. Till now, we will study only the one stage amplifiers, wherein the fourth objective is we have to know about the CMOS operational amplifiers, how it will work in the operational amplifiers. Will know about this outcome. And the stability and frequency compensation of analog CMOS circuits. From this, will know the stability and the frequency compensation of analog CMOS circuits. And then after studying, what we will get, what are the outcomes for the for that subject. And after successful completion of the course, student will able to analyze the different MOS device and its modeling. He has a different MOS. He has the capable to what is the MOS device and what are the effects. He can easily know. And then design and differential amplifiers and current mirror circuits. And he is also able to design a current mirror circuits and a differential amplifiers. And he has a know what is the trade-offs between the frequency and noise responses of the different operational amplifiers and also the amplifiers. And is analyzed to design a two-stage up amps by using the CMOS technology. And then he has a two-stage op amps frequency compensation I will study. And then these are the course syllabuses we have. First, unit 1, basic MOS device physics. Basic MOS device physics means in the name only you can see basic MOS device physics. Here we'll know the basic structure of the MOS and what is the physics incorporated in the device, in the MOSFETs, and how it will work. If you go on through this unit, the MOS IV characteristic. First one is the MOS IV characteristics, and second one is the second order effects and the MOS device models, and single stage amplifiers, and common source stage and source follower, common gate stage, and cascade stage. If you see here, the basic MOS device physics is, and first the topic is MOS IV characteristics. Means if you gone through any device, first you have to know the what is the current produced by that device. Means by giving some excitation to the input terminal, how the output will vary, is it useful for us or not, so then only you can use the device. Before going to the any device usage in the circuit, you have to know about that. So that's why here we will see the MOS IV characteristics. Means the IDVG. Here the MOS device, already you know about that the MOS device consists of four terminals. The first terminal is gate terminal, and the second one is source terminal, and third one is drain, and fourth it is not visible. If you want to represent in the symbol, you have to represent, that is called a substrate, and that is we will consider that as a fourth symbol. So, and these MOS IV characteristics will analyze by giving the gate source voltage. We will find out the ID, means output current at the drain. So that's why it is denoted by ID. And then second order effects. Already we know about very well, I think, the second order effects, nothing but the the name only is there, the second order effects. For every device, it is a chance of getting the second order effects. What is mean by second order? Before going to that, first we have to know about what is the first order. Means the first order effects are nothing but the effects which are caused because of the input voltage at the input terminal. If you giving any excitation to the device, then there is a change in the output current, then we will call those are the first order effects. Means after applying any input we will get the output, that we will call as what, the first order effects. Means the first order effects will mainly depend upon the device operation, and the second order effects are those which are the effects caused because of this device operation. Some problems will get, those problems will affect the performance of the device. The whole performance of the device will be not good when these apply voltage is high or low. That is called the second order effects. In the second order effects, we have different types of effects. Like suppose if you take the channel length modulation. What is called by channel length modulation? If you give the more voltage to the gate source then the drain, so means VDS greater than VGS minus VTH, then there is a chance of getting the channel depletion, that is channel moving towards the source, and it forms an empty or depletion space, that is called pinch off region. Due to this, the channel will be decreasing. This is called the channel length modulation. Because of this, the current output will be low, so we have to maintain a constant current. So after that, we have MOS device models. What is MOS device model? We have different types of MOS device models. Before going to MOS device models, what is the use of MOS device models? By using these MOS device models, we can find the what is the DC gain, what is the AC gain difference. We can find the DC analysis of the circuit can also be possible for the circuit by using these MOS device models. And single stage amplifiers, we have the different types of single stage amplifier. The single stage amplifiers are the amplifiers which are used to amplify at a single stage. In the name only you can say that at a single operation it will amplify the circuit signal. So common source stage, source follower, and common gate. These are the three different types of amplifiers. Here if you see the common source stage, in the common source stage we will ground the source at the, we will ground a source, and we will take the input as gate and output as drain. And source follower, it is nothing but a common drain. Source follower is also nothing but a common drain. Source follower, another name is common drain amplifier. Here we will, drain will be the ground and the input will be gate and output will be the source. If you coming to the common gate stage, similar to those, it will perform the different operations. And the cascode stage is nothing but the combination of two stages is nothing but the cascode stage. Like this we will see the different units having different syllabus coverages. After knowing all these units, we are able to know what is analog CMOS IC design, what is the use of this IC design. If you see here, unit 2, differential amplifiers and current mirror circuit. If after knowing the first unit, means MOS device characteristics, we have to apply those in the different circuits, that will be elaborated in the unit 2. If you coming to the differential amplifiers and current mirrors, here single ended and differential operations, like that we will have different amplifiers, and those analysis will be done by using MOSFETs, means like CMOS design. Here we are using CMOS, that's why we will see the CMOS circuits. And unit 3, after studying the whatever the whatever the amplifiers are there in the second unit, those will know what is the frequency response and noise response of the circuit. We'll see in this unit 3. In this unit 3 we will see the frequency and noise response of the circuits, means whatever the single stage amplifiers have and also the differential amplifiers are there. For those we will analyze the frequency and noise response of the circuit. And the unit 4 is the Cmos operational amplifiers. By using Cmos devices, how we can develop the operational amplifiers? By using Cmos technology, we can also develop the operational amplifiers rather than other MOSFETs. And what are the advantages and what is the general consideration while fabricating the Cmos operational amplifiers? We will see here. And here also we will see the both one stage and two stage operational amplifiers, and what is the gain boosting for those amplifiers. Of course the two stage amplifiers having the more gain compared to the normal single stage CMOS operational amplifiers. And here you have slew rate, high slew rate, what is the slew rate and how it will work in the operational amplifiers by using CMOS technology. And the unit 5 we need to know about the stability and frequency compensation of the circuit. In this unit we will plot those by using the um, phase margin and basic frequency compensations. And here we will use multiple systems for knowing the frequency compensation of the circuit. And after that, what are the textbook a course syllabus having the above syllabus, which textbook is better to know about this syllabus is called Philip E. Align, and it is named as CMOS analog circuit design by Oxford University Press. Is the second edition in the year of 2010. And then next book is R. Gray in the year of 2010, and it is analysis and design of analog integrated circuit. These are the two different textbooks to know the above course syllabus. This is very important to know. Before going to any subject, you have to know the author names of the textbooks and textbook name. So that's why I have displayed here the textbook names. Those will be very helpful for further knowing about the thoroughly the subject. And why analog? Why analog circuits? What is the use of analog circuits? Why analog means why you are going to analog rather than digital. Nowadays digitalization of the India, not only India, world is running towards digitalization. But why you have to study the analog circuits? Analog is the word, is not a word. Without analog we can't do the digital also, means analog is the basic thing to know about the anything. If you coming to our speech, suppose I am talking in here with analog speech only, means without and after that it will digitalized in the uh, analog. Why analog means first one is signal processing. Without analog signal can't be processed, because the analog signal is the signal which is in the continuous manner. With that is only the possibility of signal processing. With digitalization is not possible. And the transistor level design, MOSFET operate on continuous voltage, not on the discrete voltage. MOSFET will act on AC current. So that's why we have to transistor for every transistor level design we need an analog signal. That's why how to know about the analog. And interface circuits, and interface circuits also depend upon the analog. And high performance, this analog design performs high in some stages compared to the digital circuits. That's why how to go on through the high analog. And what is the use of integrated circuits? Why you have to use integrated circuits? Before going to the integrated circuits, we have to know about one law called Moore's law. What is Moore's law? Morse is a scientist. He stated that after every 6 months on a single silicon chip, there is a double of the transistors means the transistor configuration on the silicon chip will be doubled for every 6 months. He stated by it is stated by Morse. Means if you increase more number of transistor on the circuit, we will get more dissipation. For that, we have incorporated all the things into one circuit that is called an integrated circuit. And the integrated circuit will be the circuit that can incorporate all the devices into on the one single silicon chip, and it forms a one application. And if you coming to the here, what why you're choosing means due to the miniaturization. Already I told that IC integrate multiple transistors and different capacitors and resistors like passive and active elements onto the single chip. And cost efficiency. Due to this, the cost of the device will be also be less. As already you know about the first and foremost thing for the electronic student, we have to decrease the cost of the device, and you have to increase the performance, and you have to increase the accuracy. And you have also miniaturization means size have to decrease, and you have to be it is very reliable, and it has to work more years compare more years, and it has to be speed and no low complexity of the design. About CMOS, if you coming to the CMOS, complementary metal oxide semiconductor, as you know that CMOS is nothing but complementary metal oxide semiconductor, a technology widely used in the design of manufacturing of integrated circuits. Why? What is the key features of CMOS technology? Why you are using the CMOS in the fabricating the ICs means due to the low power consumption and high noise immunity and scalability and wide range of applications in both analog and digital. We have a wide range of application due to CMOS technology. So coming to the low power consumption, the CMOS circuit consume power only when switching states. Means if it is in switching mode only, it will consume the power rather than other fields, and high noise immunity compared to the other logic families, and scalability. And CMOS technology is high scalable in nature, and by using this technology, we are extremely getting a compact transistor having very thin nanometer size and wide range of applications. We have different wide range of applications here, used in microprocessors, used in microcontrollers, static RAM and flash memories, and these are the many applications with the CMOS technology. Nowadays, by using the CMOS technologies, we are getting so much of memories. We are fabricating different memory devices like static RAMs and random RAMs. If you coming to the other and how CMOS works, the basic concept of a CMOS works and the CMOS technology is here we will see. CMOS circuits are built using a combination of p-type and n-type. As already earlier I told, the CMOS is nothing but the combination of PMOS and NMOS, and the complementary design ensures that when one transistor type is on, other one will be in the off condition, and significantly reducing the power dissipation, because in the off state the other device will work and the present off state device will not work. Due to this, the power dissipation in the CMOS technology will be decreases gradually. If the power dissipation decreases means we can give more life to the circuit. And if you see here, the CMOS design means CMOS FET having the both PMOS and NMOS. If you see here, the first one, this is the PMOS symbol, this is the CMOS symbol. It is having the combination of PMOS and the combination of NMOS. uh, if you see here, this it will act as pull up PMOS, or this will be pull down CMOS. And if you see here the operation of the device, when the input voltage at the here, when the input voltage is equal to VSS means 0 volts, that is logic input 0, the output will be VDD. Means how? Means as we know very well, for a lower voltage the PMOS will be on, for higher voltage the NMOS will be on. So if you coming to here, if I am applying VSS to the input means equal to 0 to the input, what will happen? At lower voltages the PMOS will be on and the NMOS will be off, then PMOS operation will be conducted here. So, and if his input is equal to VDD, that is equal to 1, then the higher voltages, the NMOS will be on, the PMOS will be 0. That will be NMOS will in the conduction. So, if you see here, the fabrication of CMOS technology is consisting of both NMOS and PMOS. And as you know about that, for constructing NMOS, as said earlier, we will take P substrate, and for PMOS we will take N substrate. If you see here, the CMOS is the combination of NMOS and PMOS. So for that we need which substrate? Means if you want to fabricate PMOS, we will take N substrate, and if you want to fabricate P means we will take N, and N means we will take P. But here CMOS is the combination of both PMOS and NMOS. So here we have to take the substrate having good compatibility for those. For that we will create a local substrate inside the global substrate. Means we will take a global substrate that is either P substrate or N substrate. And if you take the P substrate and the opposite to that, that is if you want to fabricate the PMOS, then we will take an N substrate, and this local substrate will be known as technically well, and this is local substrate, and this is the fabrication of the CMOS, the combination of both NMOS and PMOS. And coming to the advantages of CMOS, what are the advantages of CMOS? Why you are using the CMOS? Means because of its high speed and integration and cost effectiveness. By using this we can achieve the circuit with a high speed resolutions, and by using this the integration of the circuit on a chip is very easier than other FETs, and cost effectiveness economically very less cost and very good in compared to the other fabrication techniques. And what are the applications and challenges of the CMOS technology? What are the different applications and challenges in the CMOS technologies are? Applications means already you know where we will use that CMOS circuit. Means we can use in the digital circuits, microprocessors, image sensors, analog circuits. These are the different circuits we have that mostly depend upon the CMOS technology. If you coming to the digital logic circuits, CMOS forms the basic for gates like AND, OR, NOT, and flip-flops. The CMOS technology is the able to design the digital circuits also and digital devices also. If you coming to the AND gate, it is a digital logic gate, and it can be implemented by CMOS circuit, CMOS device. And then microprocessors, all modern CPUs and GPUs rely on CMOS technology only due to this power dissipation. Due to power dissipation less in the CMOS technology, all CMOS devices and all CMOS operational amplifiers and all amplifiers related to the circuits will be used in the microprocessors. And image sensors also uses using the CMOS technologies. CMOS sensors are used in digital cameras and smartphones. And then analog circuits. Analog circuits, the widely used in operational amplifiers, phase lock loops, and other analog ICs. And what are the challenges in the CMOS technology? What we are getting the challenges in the CMOS technology mean scaling limits and fabrication cost. As transistor becomes smaller, issues like the leakage current and heat dissipation becomes more significant. Those are called second order effects. Because of the channel decrease means the source drain length will be decreasing, but for the easier jumping of electron from drain to source, but this leads to more leakage current because the distance between the gate and channel will also be decreasing, so it may increases the leakage current of the device. So this is the main challenge for the CMOS technology. To decrease the scale of the channel is very crucial, means very difficult. But nowadays the CMOS are doing very wonders, and it is operating at nanometer technologies, lower nanometer technologies also. And the fabrication cost, if the channel length is decreasing means the fabrication will also be a challenge for us for fabricating the any circuit with the low nanometer technologies. Advanced CMOS nodes requires expensive and complex manufacturing process. And what are the reference books I have taken for this course means I have taken David A. John's Kane Martin, and the name is Analog Integrated Circuit Design. In the edition, sorry, in the year of 2011, second edition. And another one is Razavi, and the name is Design of Analog CMOS Integrated Circuits, and it is also a second edition. And by Boyce and CMOS Circuit Design Layout and Simulation in the year of 2012. And the NPTEL courses, the different NPTEL courses we have, and this link will be provided in the video. By using this link also you can know what is the use of analog CMOS design and why you have to study the analog CMOS IC design. And thank you.